All right, so where we were on Friday is we finished with these, so we're going to pick up with these again as a reminder. We are on the unit circle. Since we are on the unit circle, we know as we define cosine of my angle, which is equal to my x value over r. If I am on the unit circle, it is just the cosine of my angle is equal to my x value because my r happens to be 1 on the unit circle. So if I'm trying to find the cosine of 120 degrees, the first thing I'm going to do when I'm asked to find the cosine of 120 degrees is determine which quadrant I'm in. Which quadrant does cosine, or 120 degrees, just the quadrant 120 degrees? Quadrant 2. This is in quadrant 2. And that tells me that my cosine, of my angle should be a negative number. So it should be negative some value. Okay? Because of the fact that we are landing in quadrant 2, I know my cosine should be a negative number. The next thing I'm going to do is say, okay, I need to find my reference angle. So I'm going to go the shortest rotation from 120 to my closest x-axis. So I know that 120 has a reference angle of 60 degrees. Okay? So I know that the cosine of 120 degrees is the same thing as the negative, because I'm in quadrant number 2, the cosine of 60 degrees. So it's my reference angle, then I just have to remember if it's a positive or negative based on where my terminal side is. My terminal side is in quadrant 2, so it is a negative. So now I just do the cosine of 60 degrees. So I come up here to this quadrant, because this quadrant will give you everything that you need. You just need to remember to put a negative or a positive on it. You don't have to do any work if you have this first quadrant. So I'm looking for the 60, and if I find the 60, it is right here. Here's where my 60 is. The cosine, as we know on the unit circle, is just the x value, and so it's 1 over 2. But since I'm in quadrant number 2, that this is going to be the negative right there, because I'm in quadrant number 2 where my terminal side is. So my final answer is going to be negative 1/2, and that's going to be the exact value. Yes?
Can we go over example C on page 2 real quick?
We are, normally I would say yes, but we are behind, and I need to have that test this week. So I will be happy to do that example with you out on office hour. Absolutely be happy to. Okay. So that's how we were doing those. So when we take a look at D, we have 13 pi over 6. Again, I know that we did this in class on Friday, but I'm just going to talk very briefly about this. We need to figure out where 13 pi over 6 is. What I know is that if I had 12 pi over 6, this would equal 2 pi. So if I have 13 pi over 6, which quadrant do I land in? Quadrant 1. So you need to pull off one full rotation, so you find the coterminal angle for this one, and the coterminal angle for this is going to just be pi over 6. All right? So now we're doing calculator work, so get your calculator out and do these to 4 decimal places. Be careful on B. With B, you do need to convert your degrees, minutes, and seconds to decimal degrees. So on B, make sure you take that 19 minutes and turn it into its decimal equivalent before you put in your calculator. When you're doing this in your calculator, make sure that you are in the correct units. So you're going to have to go back between radians and degrees, back and forth. So for the first one, you put that in your calculator. Do make sure that you are in degrees and you get 0 point, what did you get? 8192? Do you all agree? For the second one, you still be in degrees, but you do need to take that 19 minutes and convert it into its decimal equivalent. You put it in your calculator, what do you all get? 0.75? 7583. All right, any questions so far? Yes? Depends on what you have. So in these, you have to be in degrees. For this one, you have to be in radians. So when you put this one in your calculator, you're going to do the sine or cosine and then 5 pi divided by 7. And when you do that, what do you all get?
I got
-0.142857, so 1.429.
I didn't get
What did you all get?
that. I got 0.99923311456. But I just put it in my calculator just like that.
In radians?
What?
You all in radians, yeah? And so what did you get?
0.99923311456.
0.9923?
Yeah. 3 nines.
3 nines?
Yeah.
And then a 2?
233. Yeah.
Do you all agree?
Yeah, I got that too. I got an error.
Cool. Let me bring up my calculator here. Let me put this on pause and bring up my calculator. So for the last one, you do need to make sure you're back into degrees.
In degrees or radians?
In degrees, last one is in degrees. So when you go back into degrees, tell me what you all get.
I got -0.9768.
Oh, you gotta actually change it back.
0.9768? 8?
0.987688.
Do you all get a negative?
Negative. Yeah, I got that.
Okay, and we all agree that this one was incorrect. It was like a negative 0.6 something. I'm gonna leave it at negative 0.6 something. Okay, did anyone get something different than a negative 9.9876? Okay, cool. Let's take a look at this one. So, I'll wait. Okay. On this one, they're asking for, and this is going to be really important to read what it's asking for. We want all the angles that satisfy it. All of the angles that satisfy this. So I have to write all the angles that satisfy that. So I get out my unit circle, and I look to see where sine is a positive 1/2. So I'm trying to find the angle that gives me a sine is a positive 1/2. So it's like 30 degrees, or pi over 6. So when we have theta is equal to pi over 6, that satisfies it. Is there any other value on the unit circle in radians that also satisfies it? Where else is sine positive? In the second quadrant. So where in the second quadrant in radians do I have the sine, which is the y value in the unit circle, equal to a positive 1/2? So it also happens at 5 pi over 6. Do you all agree to that? If I look at my unit circle, those are the two angles on the unit circle that produce a positive 1/2 when I do the sine of that angle. Do you all agree?
Does 5 pi over 6 is 150 degrees?
Yes. I'm going to almost always be in radians because I'm setting you up for calculus, because in calculus everything's in radians. So does that answer the question though? Is that every single angle that is going to satisfy those equations? Is that every single one?
Oh, you can go on.
I absolutely can continue to go around the circle, and the way I do that is I say plus 2 pi k. So every coterminal angle to pi over 6 will work. And also, same thing here. Every coterminal angle to 5 pi over 6 works. And that's why it's really important on this is you're looking to find all the angles that satisfy it. Those are your answers. Now, if it would have said, I want all the angles that satisfy it in here, in an interval, then that's going to give me a different answer. Then I'm just looking for specific angles in one rotation. So if it asks for all the angles that satisfied in this interval from 0 to 2 pi, then my answer would have been simply just pi over 6, 5 pi over 6. So you really have to pay attention to what the directions are asking you. Do they want every coterminal angle, or they just want certain angles within that rotation? Does that make sense? So go ahead and solve the rest of them in radians, please. So go ahead and solve the rest of them in radians, please. My two answers are when theta is equal to 5 pi over 4 plus 2 pi k, comma, and then you're going to do the same thing, 7 pi over 4 plus 2 pi k. You do have to break them apart individually, and there's going to be a reason for it later when we get to solving them and we have to do some divisions and multiplications. Yes?
What is the k for?
So k is an integer, so this is telling me that these are coterminal angles. So any coterminal angle to 5 pi over 4 will be an answer, and any coterminal angle of 7 pi over 4 will be an answer. So this part right here is the coterminal part. It's telling me I have coterminal angles. Going on to the next one. If I'm asked for square root of 3 over 2, in which quadrants is cosine positive? 1 and 4. So cosine is positive in 1 and 4, so I'm looking for 30 degrees, which is again pi over 6. So I have pi over 6 plus 2 pi k plus. And what's the other one? So 11 pi over 6 plus 2 pi k. My pluses are not looking very good today.
So, if I were looking at this thing here, how would I calculate that 11?
11. So the question was, if I wasn't looking at the unit circle and I'm trying to figure out where else it happens, how do I find the 11 pi? Well, I know that I'm in quadrant 4. For cosine to be positive, I'm in quadrant 4. So then I consider this part, the pi over 6, the reference angle. So what angle would have produced that reference angle in quadrant number 4, which is 11 pi over 6?
Yeah, how did you get it? I mean, how would you minus 2 pi?
So I just take 2 pi and subtract off pi over 6.
So you subtract it from 2 pi.
Yep. All right, how about this one? Go back to red. What is it? How was that? Okay, cool. So here we are now in the fundamental identity of trig. And this was the one where when we started with 10.3 and by mistake we were kind of having a hiccup. So now we're back to this. So we have the sine, what we know is the sine squared of my angle plus cosine squared of my angle equals 1 all day long. So I'm trying to find each one of these, and I can do it by this fundamental theorem. This fundamental theorem will work every single time. So if I take a look at A, and I'm asked to find what angle, find the sine of alpha. I don't even need to know what the angle is, I just want the answer. That's all I want. What I know is if I use this formula right here, that I can find the sine of it, and then all I have to, sine squared, and then I just have to take the square root of it. So I know that the sine of alpha, sine squared of alpha, plus, and then I replace this with the fact that I know that the cosine of alpha equals 1. So I put in a 1, that's the answer, and I square it, is equal to 1. So what I really have is I really have the sine squared of alpha is equal to 1 minus 1. So the sine squared of alpha is equal to 0. So alpha, sine of alpha, taking the square root of both sides, is just 0. Let me do one more. You want me to do B, C, or D?
C.
Okay. So I take a look at C, and I'm going to do the same kind of thing, as I know that I have the sine squared of alpha plus, I replace cosine alpha with 2/5, but I have to square it. and it's going to equal 1. I'm using the fundamental theorem here. So now what I have is I have the sine squared plus 4 over 25 is equal to 1. So I have the sine squared of alpha is equal to 1 minus 4 over 25. So what I have is the sine squared of alpha is equal to 9 over 25. And what I did there is I made the same common denominator, so I have 25 over 25 minus, and that should be a 9, or that should be, what was it, 9? What did I have, 4? Oh, so it should be, sorry, that shouldn't be a 9. So it's minus 4 over 25. And so here, erase that, that should be 21 over 25. Now I'm going to take the square root of both sides. So I get the sine of alpha is equal to plus and minus the square root of 21 over 25. So I have the sine of alpha is equal to plus and minus the square root of 21 over 5. Now I'm going to go back to what it's given me in terms of which quadrant I'm in to determine if it's a positive or a negative. So I go back over here, way over here, and I want which one on C, the positive or the negative one? I want the negative. This is telling me right here I want the negative one. So that must mean I'm in quadrant number 4.
How does that tell you?
Because it's telling me I want my answer to be less than 0. So I come back over here, and my final answer then, by taking the right value for the positive and negative, sine of alpha is equal to negative square root of 21 over 5. And that's my final answer. How was that? Okay, cool. Please do B and D. So if I'm taking a look at B, I'm going to use the same thing as I'm given cosine. So I have the sine squared of my angle plus cosine gets replaced with negative 4 over 5 squared is equal to 1. And then I bring everything to one side, and so I get the sine squared of alpha is equal to 1, and then it'll become minus 16 over 25. All right. So first of all, I'd never do it this way. I would never do this way. This is way too much work for me. I'm not doing this shit. So what I'm going to do is I'm going to use x, y, r all day long. And the reason I do this is because you're going to see some videos that say, oh, do it this way. No. I'm going to do x, y, r all day long. So I'm going to go over here, and I know the cosine of my angle is negative 4 over 5. What is x? What is r? How do I find y? So it is my r squared, which is 5 squared, minus my x squared, which is negative 4 squared. And so I end up with a square root of 9, and so my answer is 3. Right? There's a plus and minus here, and I just need to figure out which one I take at the final answer. So I come back over here, and I'm in quadrant number 3. Which one do I take, the positive or the negative of that 3? I take the negative. So I know the sine of my angle is equal to negative 3 over 5, and I walk away and I'm done. That's how I would have done it. But there's a fundamental theorem. You can use it that way. I don't ever use it that way. So looking at this one, I'm going to do the same kind of thing. What I have sine, so what do I have, y or r or x? What do I have? Y is 1, r is what? 3. I need to find x, so it's going to be plus and minus the square root of 3 squared minus 1 squared. So I end up with plus and minus, and what do I have a square root of what? 8, which is plus and minus the square root of 2 root 2. I'm looking for cosine of my angle, alpha, that's a really bad alpha,
Why are you minus one squared instead of value?
because I have, the question was why do I do r squared minus the y or the x squared, is because I have r squared is equal to x squared plus y squared, and if I'm solving for one of these, I need to subtract it from the r. All right, so going back to this one, my cosine, which I have the x, cosine is positive, and so I'm going to use a positive 2 root 2 over my r, which is 3, and I'm done, and there's my final answer. Do you prefer using this, the fundamental identity of trig? Cool. Use the fundamental theorem of identity for trig. I'm good with that. Do I use it? No, not unless I have to. I don't use it unless I have to, because it's easier to do x, y, r. Okay? So this is where you all, if you love SOHCAHTOA, it's like, oh, SOHCAHTOA, please don't do it. Use x, y, r still. Use x, y, r still. So we have the angle is 30 degrees. The side adjacent to theta has a length of 4. What is the length of the hypotenuse? How do you know? So we have the fact that we're using x, y, r all day long. So this is 4. The one adjacent is 4. This is 30. Right, so you want to use sine or cosine? Which one do you want to use? Okay. If you're using sine, you can have the sine of 30 degrees is equal to 1/2. Right? Where I have the y value over the r value. Is that going to help me find what the hypotenuse is? Is the sine going to help me? No, sine is not going to help me. What do I want to use instead of sine? I'm going to use the cosine. So I have the cosine of 30 degrees is the square root of 3 over 2. But that is the square root of 3 over 2 is equal to my r value divided by my x value, or my x value divided by my r value. My x value divided by my r value. R is what I'm chasing. What was my x value? What was the side of the one adjacent? 4. Now you just solve this. So we multiply both sides by r and divide both sides by square root of 3. So r is equal to 4 times 2 divided by the square root of 3. So my final answer is 8, the square root of 3. How was that? Want to see another one? Okay. So on B, I have 59 degrees. The side opposite of my angle is 117.4. Which one do you think I'm going to use? So I'm going to draw a picture. Here's my 59 degrees. Here is 117.42 on that side. Which one do you think is going to help me get the answer? The sine. The sine is going to help me because the sine is the relationship between my y value and the r value, which I'm trying to find. So I'm going to use the sine. So I'm going to do the sine of 59 degrees. Somebody with your calculator in degrees, tell me what that is equal to. What is it? So 0.857. Now remember, this is equal to my y value over my r value. So this is 0.857 over 1. I'll give you my r value. Is equal to, I have my side of 117.42 divided by my r that I'm looking for. So I multiply both sides by r and divide by 0.875, R is equal to 117.42 divided by 0.857. What is my R value? What is it?
234.4.
Do you all agree 234-ish? In your calculators? 137? 137-ish? So you all get 137-ish? Okay, so that's how you do those. Do I have any more? We're done with this section. Cool, done. Tomorrow we will finish 10.3.